Hey guys, we got a lot to get to. There's a lot to show you, and there's a lot of high level type stuff that I want to go over as well as the technical side of roundabout design. So I'm just going to jump right into this, and we'll start off with ICD placement. So this is a little background. This is a project in Traverse City area along US 131. Um, we have the right of way and kind of the topo shown here in these quadrants, and you can see we got three commercial businesses in a residential area. So when I'm placing this ICD, this right of way space is going to be probably one of my first considerations that I'm going through. Um, Probably want to steer clear away from this residential area just because it can be a little bit more difficult to get right away, and it does seem to be like the tightest quadrant. So that's what's standing out to me right away. On the planning level side for Rodell analysis, this came back as needing the capacity for 2 lanes along US 31 and 1 lane for the South Long Lake and J. Matty Parkway. So this will be a combination roundabout, which puts us at about that ICD range of about 180, the higher end of the single lane. That should be able to accommodate both. So with that, I'm just going to jump in and kind of place this on the scratch level, rough idea of where I want my ICD to be. Again, my consideration here is trying to avoid this right-of-way impact, but this placement off the alignment is going to affect our some of our performance checks that we'll run into later. So really don't want to get too far away from here. The farther away from here that we get, the more curvature and things like that we'll need on one of these approaches or both. So I'm thinking to start out maybe going 10 foot. If we place it right at this alignment, maybe going out probably 10 feet west, and then, whoops, I did not mean to go that way. 10 feet west and 10 feet south. Doesn't have to be exact, but this will hopefully limit this, and we're still within the right of way in the other quadrants. And then with that, some considerations then, what you're looking at kind of goes back to what we touched on before, which is a really important part, and it has to do with the entry alignment. So we really want to hit alternative 1 or alternative 2 and have the entry alignment either be through the center of the ICD or off to the left, and that's going to help with deflection. Width, we can always we have kind of a wider ICD, so we can always expand that out a little bit to accommodate the design vehicle, but that deflection can't really be changed too much when we're offset to the right, and we're going to have a really hard time getting speed under control, which is kind of one of those bigger issues along with the design vehicle. So with that, as you're going westbound, this alignment is going to be to the right of the center of this ICD. So I can see already just from knowing that this alignment is going to have, this roadway is going to have to curl down a little bit as it comes in to get the deflection that we're going to be looking for. On the other side of things, for eastbound, this alignment is on the left side, so this one's already kind of in pretty good shape. But one of the considerations that you might have then here is that you really want some type of curvature happening before the splitter island, especially on a higher speed roadway. So if we're already kind of aligned to the left, which is what we want, but we need to slow down traffic before that ICD, I could see a reverse curve happening before the splitter island to get traffic to start, slowing down and things as they approach that splitter island, and ultimately though kind of coming in at that same alignment that's there. So those two curves will kind of counteract each other, but the curvature will give you a little bit more speed control coming in. In terms of the north and south, I think this placement looks pretty good. Again, to the fact that we're trying to avoid right-of-way impacts in this northeast quadrant. The main reason because of that is that this alignment, we moved it west, the ICD west, so this alignment is already coming in to the left of the ICD, meaning we won't have to push the roadway out towards this right of way very much. It's already kind of curled in, and then that kind of means that this side's going to have to go a little bit farther left because we're on the right side. Luckily, we have quite a bit of right of way down here that we can kind of curl this roadway to the left and get that alignment on the left. So with that, we kind of, with this curling down, we don't impact that northeast. With this already being on the left, I think that placement makes a lot of sense. And I'm just going to jump into, this is an iterative process, so I'm going to jump into how I design a leg, and then eventually there will be a video on some design calcs once it's all kind of complete. And then you kind of just reiterate that process. You go back through and you get your fastest pass. But I think this is a good idea, at least high level thought process in terms of the placement of the ICD. Ideally we could have it right in the center of this whole thing. And if that was the case, maybe there'd be a little bit of deflection, but I think we can work with this. So I'm just going to jump into designing this east leg here. I have my construction file already kind of referenced. This is going to be a 3-lane segment, center left turn lane, and two US 31 travel lanes, and it's built off of this alignment here. So I'm going to go ahead and find a pavement marking line. We'll start there. We'll use this solid broken yellow pavement marking, and I'm going to live in this kind of geometry ribbon here, and we'll do an offset partial of 6 feet, this being that center line, and I'm just going to take it. This isn't necessarily the limits. It could go back farther. It really depends on this curvature and everything here. With that, I'm going to try and, for these faster highways, you really want 150-foot length splitter island. So I'm just going to take a peek at what that might look like. 150 feet being minimum around here. I think we could probably increase it a little bit, maybe go to the center of this. That way this can turn left and out. You don't really want to go much farther. So maybe targeting around right here, 185 or so would be my target for that splitter island. And then from this, I'm going to try and stay out of the technical side a ton. Maybe just like speed this part of the video up, but it's kind of the same thought process for all 4 legs. But I'm going to go arc from element on this, and that way it can be adjusted later on. And I'll just go from the end. Here, this is going to be that left curve, trying to get this alignment to be down in this section down here and then come back up. So really you want this radius to be, you want it to control speed, but you also don't want the limits of this radius to come way back here. So if it's really flat, to get that deflection that you want, the radius is going to have to start way back here, and I don't want that. But at the same time, you also don't want it to be too sharp because this is that first curve coming in. So people, potentially are going 50 miles an hour as they're starting to approach and things like that. So I'm thinking around 3,000 feet is a good starting point, and then seeing where that deflection line. So if I'm starting my splitter island around here, is that going to be enough of, we'll trim back, is that going to be enough deflection off of this alignment? I know we went 6 feet plus this little bit here, but it really depends on this ICD center. I don't know if it is just by looking at it. I'm going to pull this back maybe to about here or so. And as I pull that back, it holds the same spot, even more deflection. So I think that's a good spot to start out with. And then from that, I'm just going to offset this entire element. We got that, lane we want to keep going at 12 feet. So maybe something like that. And then from here, I'm going to start developing out my splitter island so I can get my edge lanes and stuff like that all drawn in. For the nose, I really like to use a do not construct level. I'll kind of tell you why, because sometimes that nose location will change depending, and I like to put up some geometry beforehand that helps me adjust it without ruining a bunch of rules. So I'm going to do an offset partial off of this this pavement marking line. And really this kind of goes back to a standard of there needing to be about a 3-foot offset from the pavement marking line to that entrance of the splitter island, and I can kind of show you what that looks like here in a second. This is in the NCHRP report 672, and you can kind of see right here, this is the offset that I'm talking about from the splitter island nose to where it actually ties in, and they talk about it here as an offset from the pavement marking. So I like to kind of put that in there. And then we have 9 feet remaining out of our 12. So I think it makes sense to do a 4.5-foot radius on this nose, so that way the nose takes up the rest of this section. So I'm just going to do an offset entire element of this at 4.5 feet. And then I'm going to do it again out on this edge line. And then from there, you know, if we turn off kind of this, from there we can get some of these lines drawn in, and these will help control your splitter island nose. So if I take this line perpendicular to that, sometimes I have to draw those dummy lines in, but now we have that line perpendicular, and I'm just going to offset that the same thing, 4.5 feet, and make this little box here. So then with that, I'm going to jump to my surfacing and start the splitter island nose in the travel way, and we'll do the HMA edge. And I'm going to do an arc between points, start and pass through, except that, and I'm going to, these rules will actually like stay you know, associated. So the beauty is that I can take this line, and if I decide to change this line or this splitter island changes, I can take this geometry with me. It still remains true to these 2 lines as well in terms of that curvature coming in. And these lines are all attached to my pavement marking line. So everything's kind of built off of itself. And this is going to help in that iterative process as you're going through, because that way, if a radius needs to be tweaked to meet a speed parameter or something like that, you can do it on the fly, and everything else should kind of update along with it. So in here, I'll turn back on that pavement marking line if I can find it. That one. And then now from this point, you know, it really likes to kind of, this curve I've found out fits pretty well in terms of having a 100-foot radius and being that 25-foot offset. So I'm going to extend this line actually a little bit beyond, and then I'm going to do an arc between elements to build this, and I'm going to select this and this line, and we're going to fit it in at a 100-foot radius just like that. And we're just going to trim back, because I don't really care about trimming this line too much. We can actually bring this line back. We didn't necessarily need to keep it there. But now this line is trimmed up into there, and we're starting to build that nose of that splitter island. So from here, you know, I can already tell with it being, we can't just curve it right in right away with how far away we are. So we're going to put a tangent section in here. I like a tangent section better than a reverse curve, just because it's going to work against where we're trying to put that alignment in. So I'm going to go align from element on this and start from that end and just shove out a tangent, something like that. So now as you're coming in, you know, you got your curve coming down, and then eventually we'll loop in. So now this point you can see is quite a bit lower than here. So we're going to get that deflection that we want. Now we just kind of have to worry about how far down are we going to go, but that can be adjusted, you know, using this tool back here. So if we want, we can bring this farther, you know, closer in and build it off that way, or we can keep it kind of in this area right here. And now for that curve coming in, and this is kind of a big thing I know, is making sure that the roadway is, you know, tangential to that inside diameter. Talk about it a lot throughout NCHRP, and what's cool is that ORD actually has tools now to kind of connect these. So a continuous continuation of the inside entry curve tangential to the central island. That's kind of huge in terms of your entry angle. So what we're going to do is I'm going to take these do not construct lines again, and I will actually offset the entire element of this. That central island is actually going to be, I believe, 30 feet in from the 2-lane. So it's kind of hard to imagine, but essentially there's going to be a single lane here. So this will actually be like 10 feet out. There will be kind of 3 2 ICDs. This is the central island. So in this section here, we're going to have 30 feet, 2 lanes being able to exit. But in this section here, it'll just be this 20 feet. So it's a little bit of a combination. But so an arc, we're going to take a line to an element. And we're going to take this central island. You can hit Alt to kind of go in between these. But I'm going to use this one here on that end. And now I'm forcing this to be tangential to my inside diameter. So that rule, if I connect these two, that rule will stay that way, and that ensures that I know that my arc is going right into that ICD. So then I'm going to jump back to my HMA level, and I'm going to do an arc between elements here. So I'm going to do a simple arc, and these typically are around like 100 to 120, and they need to be adjusted. So I'm gonna do both, and that way it'll trim both of them as I go. So obviously I'm pretty far away right now. This isn't even close, but you can take this then and kind of bring this in. For this one, since what I was talking about is this is going to be a single. This is actually the circulating roadway width here, not the total ICD. These ones will come into this outside ICD, but the east and west leg are going to come into, to make that a single lane. So you can adjust that line then, and now this curve is shooting that traffic right into the roundabout. So I don't mind that as a starter. I think that looks pretty good. And then when it comes to this exit, I like the exits to be as low as possible. So if this can come off, and you really don't need any radius on the exit, because what's going to control that speed is going to be your R2 movement, your V2 movement going around this radius, and then how fast can you accelerate to a point of interest. So these can end up being really, really tangent to the bottom and really be down here. But I don't want to encroach on this right away, but I'm thinking I can kind of shoot this and just make it kind of a tangent into this curve. And then really not have much curvature on it at all. For this, we do need to have a hawk signal though, so considerations for pedestrians are up there. You need kind of the setback of about 50 feet or so for 2 cars to sit in this area to allow pedestrians to go and not impact the capacity of the roundabout. So that is a consideration that I need to keep this the splitter island pretty wide, at least in this area. So because of that, I might go and arc from element and take a spot, select this, but you don't necessarily have to go from here. I'm already kind of thinking if I go from here and I shoot out, this is going to be too thin in this section to fit that offset sidewalk that I need. So looking at it, I think I'm going to select this, and maybe I'll go from maybe something like back here. Way too far back. Maybe something back here. Even still too far back. So again, iterative process. And you can always kind of adjust this too. But maybe something, this isn't even really necessarily ideal. I think it's still too wide. So we'll go right there. How's that looking? I think that looks pretty decent. So we'll cut that in, and you can draw it really to wherever. You can put these do not construct lines on this end, and kind of it just gives you a little bit more freedom to edit. I find that the exit curvature just isn't really that big of a priority. I never really have an issue with it, so I'll just connect typically, you know, a line in here, and it honestly looks like this is basically going to end up being a tangent, which is kind of nice. Trim back. And now really there's almost no curvature to this exit. Obviously I'm creeping in down here, so I might have to adjust this. This might have to come back or change. But again, everything's built off that, so it can all kind of adjust as I go. And then, you know, from these you can put some arcs between elements on this and trim these back if you wanted to, if they're, you know, bugging you or anything like that. So for some reason this didn't trim back, and I'm assuming it's because of that. There it goes. And then between elements, and you can trim this. It's not going to change anything. It's still, maybe that one has a 4 and trim back. I can still adjust this by just grabbing the line. So it's just going to give me a little bit more freedom to play with. And then you can put an arc between elements in this as well. So if I didn't want to know the radius, it should be 80. Ah, I clicked the wrong spot for it. Great timing to crash. We will be right back. All right, we are back. It did crash on me, so I don't know what I did wrong, but got it all fixed, and I think now kind of jumping back in, thought kind of hit me in terms of this tangent being here, kind of coming into a curve. I'm not like a huge fan of that, so I think I'm actually going to get rid of this and toy around with the idea of putting in a curve just directly between the two elements of this splitter island nose and this, and keeping it around. I like this 1400. I kind of played around with this a little bit before, so I kind of like this 1400. I think it curves a little bit better into the natural path of the pavement markings, and then I'm just going to trim that back, and then from here we can always do these as trim this back this way and have that the same. So there's a lot of different options that you can go through, but I think I like this one a little bit more. I think we still have the width that we need in here to kind of get that. So that crossing is going to be probably like around this way, and then it's going to have to jog back a little bit to give more space on the exit. But I'm still not sure as to, you know, whether or not we bring this forward a little bit. If we bring it forward like that, you know, it does change. You see how it changes, but everything else is still connected. You know, this is still connected to the inside. So that's kind of like why I like setting this up. So if we have too much deflection, we don't want to creep in on this right away. We can adjust that, or maybe, you know, fastest path-wise, we're not getting the speed that we need, so we do need more deflection. So we can go ahead and pull this back a little bit and see what that does to the overall geometrics. Helps with the iteration process. So from here, I don't have a ton more time left that I can go with on this, so I'm going to start laying out my edges. Really, all the other legs are kind of the same. You're just going to tie into to this outer ICD together. So with that, I'll just kind of jump in and start offsetting. I really like to kind of, you know, this first one, offset this entire element. You know, we'll start out at that 12 feet. So definitely want to connect into that. Don't need to mirror it for now. But we do need to widen this, you know, even in terms of single lanes. You know, typically you're at about 14 feet by the time the ICD comes in. That's going to be based on your design vehicle, so that will change. But from my experience, even for a single lane, this is typically 14, and it widens between, you know, 16 to 20 feet for the entrance, depending on that design vehicle. And that really, again, you're fighting two different things here. The curvature is great for speed, you know, on a passenger vehicle and keeping those volumes low, which is good for safety and everything else. But that curvature also directly affects your ability to get the design vehicle through. So it's that balance between. So on here, you know, we need to go, in my mind, I want to start my second lane probably right at the beginning of the splitter island. So somewhere this might need to be, you know, pushed out to 24 feet wide, and this is where my widening's kind of starting to happen. You do want to make sure, you know, with opening a lane and tapering open, it's not as big of a deal, but on your exit, if you're closing one, that you're meeting those guidelines for merged lanes and things like that. You're you know, L times S squared divided by 60 if it's under 45 and stuff like that. So from there, like I don't mind this, at least to start. Bringing that, this will give you the ratio, but I don't mind that. And then keeping this, you know, maybe we offset entire element on this tangent as well. This would be that 24, but you know, we can connect these in between. It looks like this curve kind of is the biggest reason. So it comes down to this line. If I just extend that to there, should connect in. You know, here I think we're gonna want to keep on expanding, out a little bit. If we keep this ratio kind of the same as this ratio, then ideally we can, but we do want about 30 feet, I think, for an entrance for two. And the main thing being there, we have a truck apron in between, kind of a chevron, where trucks get to use a little bit of that extra lane. You know, from here then, you can do the same thing. You can attach one of these do not construct lines to the outside edge, which I'll probably do in this situation. Just gives you a little bit more freedom, more flexibility. So going to an element and coming off of that, and then going back to your curve. These are going to be different in terms of their radius. So keep that in mind. They don't have to match. So maybe making this one 110 or whatever you want, trimming both to start, and then you kind of got to adjust this line. And this is where you're going to get the question of what your entry width is and things like that, because again, these radii are typically never actually the same. So a good check on this that I found was taking a do not construct line and building a line off of that at a certain distance you're trying to target. So right in the beginning here, I'm going to do an intersect snap on this line intersecting at this ICD here. And then from there, I'm going to select the center circle snap, and I'm going to point back to this radius, but I'm going to give it an exact 30 feet and click, and it should go 30 feet directly perpendicular from this intersection at this point. So this is my entry. This is what I'm going to decide my entry width is. So from this point, you know, you can kind of already tell it's not wide enough, 25.22 feet. So I already know there's no way I'm fitting two design vehicles in this area. This has got to be widened out closer. So this is where I can start using these to kind of give me a little bit of an adjustment. If I bring this down, it gives me a little bit more deflection. You know, that's one option. That's probably great for the design vehicle, but that will change then some of your fastest path parameters and things like that. So this is the freedom that you get with setting it up this way. As you're doing iterations, you can tweak these things, go back through your fastest path, run your auto turn, and then see what works for you. Excuse me. So this might be one way that I set up, and as you're taking this exit and building this one, you can tie that into this leg as well. And really you're going to do kind of the same thing on this side. So I would probably take, you know, offset over here, entire element, start at 12. Oops, always forget this. Start at 12 and kind of repeat this process on the exit So I know I'm tying in there, here. Again, maybe I want to be maybe I want to be at 18 feet and kind of, because I want to kill this lane probably as soon as I have the crossing. I want to be at 2 lanes up until the crossing, and then after that I want to taper as fast as possible. If not, you get kind of people trying to speed past each other and things like that. So I could see this kind of tapering down, and then doing something like in terms of an offset on this end. You know, these obviously aren't going to match up perfectly, but if we pull this back a little bit from that piece, you know, now if we get that offset at 18, these might work out. It doesn't always have to be exactly 18 either, just an offset off of that. You can take from this line really and just go an arc between elements if you wanted to to this outside and do, you know, like a 120 or something, trim back, and then obviously you're gonna have to change a lot of this out to be, you know, 24 feet, or but really, you know, we can flatten this out to be like 300 if we wanted to, and kind of give you something like that. Again, you know, you're seeing this as like kind of a straight shot. I'm not really too worried about that. The idea being that this movement here is gonna slow traffic down. They're gonna be at 20 miles an hour coming around this curve. That the point of interest being back here, you know, they'll only be able to accelerate so fast from 20 miles an hour up to a speed that I think will still be, as long as this V3 speed is within 15 miles an hour of this V2 speed, then you're within the parameters on it. So I think we'll be able to achieve that even with this straight kind of shot. And the good news is about this is that the entry angle on this leg coming in between these two legs is actually going to be really good because this is so far lower. And we can do the same thing over here. We can kind of set up a line between points, use that intersection. So this line does come through, take that intersection. It is a curve. And on these, you know, maybe we want them a little bit less, maybe 28 feet. As a target, excuse me. So, you know, maybe we could widen this out a little bit more, even put this at like 1,000-foot radius to kind of get that 28 feet and that shot coming in. And we can always, you know, take this and adjust this taper and things like that. But yeah, this would be an example of laying that out, this leg, and really you just kind of repeat it, and then we'll eventually get to the fastest path. So stay tuned. All right, so after some tweaking, snap my fingers, and just like that, Roundabout has been made. Just wanted to kind of go over what that finished product looked like after everything was completed. So again, this kind of this curve coming in at 3,000 feet, kind of bringing that deflection down. There was a few things got altered in here. This is kind of a bigger radius once I attached all this together. This still kind of shoots the way I was talking about. We're at that kind of 24-foot offset in this section. And then as soon as that gets done, it starts tapering down. This is that offset in the sidewalk, allowing 2 cars to kind of sit without impacting the roundabout there. On this end, we did need to fit in a reverse curve, kind of speed control traffic as they were approaching. So you're going in and we push them out on a 3,000 curve out here, and then coming back in at a 1,500-foot curve, tying in that way. And between the two of these, you know, really if you extended this line out, it's pretty much like in the same spot. We went a little bit farther left, but not much. But we did get some curvature in there to allow a little bit more speed control before entering the Splitter Island section of the roundabout. These are the chevrons kind of that I was talking about before. That's going to help, you know, trucks are allowed to basically use this central area without influencing the other side, and then this is the 2-lane section of the through movement, and then here's the single lane. So if you turn on your your scratch level ones, this is kind of what I was referring to in terms of, this is our main ICD out here. Here's our single lane ICD right there. This is really just the center of the 2-lane that helped me construct these pavement marking lines, and then here is the inside central island. So you have single lanes going this way. Just kind of took some radii and curved it out. We wanted to have a center left turn lane for this, so that way we could pop off right after and take a left in there. And this one ended up being a shorter nose, 50-foot minimum. So this is exactly at 50 feet, and that would allow traffic to kind of hop in this lane and take that left turn before we kind of kill that off coming down here. So this is, this would be a geometrically complete. The next thing we would do on this is start to run our fastest path and truck turning movements and entry angle and all of our performance calcs, and then we'll create the geometric memo from there for base plane submittal. So stay tuned.